Good day, students. Today we will be looking at vectors in 2 dimensions in further mathematics. My name is John Obodo. So today we want to consider vectors and the two-dimensional analysis of it in terms of I and J dimension. That is talking about in mathematics parlance, Y and X axis. Okay? So, first of all, we have to understand what a vector is. What is a vector? The term vector is defined as a quantity that have magnitude and direction, okay? Which is opposed to what we call scalar. When you learn that in physics, you learn that a scalar quantity is a quantity that have only magnitude but no direction. So we say that in vectors, we are going to encounter different types of vector. When we talk about types or examples of vector, we have velocity, we have displacement, we have force field, force, and so on and so forth. But when you say scalars, examples of scalars, we have length, we have volume, we have area, and density, we have temperature, and energy, and potential energy, etc. These are all scalar quantities. But in the case of vectors, we have force, velocity, acceleration, displacement, torque, momentum, gravitational force, electric and magnetic intensities, and so on and so forth. So that is two wide areas we are looking at here, scalars and vectors. But our major concept here is vectors. A vector quantity is represented by a straight line segment, as you can see it in the diagram. When you have a diagram of this nature, we have a vector PQ. A straight line segment can represent a vector, and this vector can be given as PQ, represented as with direction. That is how to represent it mathematically. Okay? So a vector represented in that form, as we have seen on the slide on the board, we can draw the line segment from P to Q. That is a typical vector representation. What are the types of vector? We have different types of vector based on classification. We have what's called the unit vector. A unit vector is a vector whose magnitude is unity. We have the free vector. A vector whose position is not fixed in space, and thus the line of action of a free vector can be shifted parallel to itself. Displacement is an example of a free vector, okay? So we have localized or bounded vector. A vector which cannot be shifted parallel to itself, whose line of action is fixed, is called a localized or bounded vector. We have a coplanar vector, or what we call coplanar vectors. These are vectors which lies on the same plane. 2 or more vectors that are acting on the same plane. When we have 2 or more vectors acting on a plane, we have 1, 2, 3, and 4, and so on and so forth. You call them coplanar vectors. If they are forces, you say coplanar forces. We have concurrent vectors. These are vectors which act towards a point or pass through a fixed point, or they act towards a point or away from a point. So we have 2 more vectors. One acting in this direction, another one acting like this. These are 3 vectors. Let me call them F1, F2, and F3. These F1, F2, 3 vectors are what we call concurrent vectors. Okay, so we also have negative vector or negative of a vector. The negative of a vector can be described as the negation of the vector. If I have a vector PQ, this is a vector PQ, okay? The negation of vector PQ can be given as this. Let me say this is equal to this. So the negation of it, negation of PQ vector is minus this. And the diagram can be drawn as shown. You can draw the same diagram, but in this case, the direction will be reversed, as in we have P and Q, but this time around negated. So we have this. So in negation, a vector is a vector that acts in the opposite direction with respect to the real vector or the original vector. Okay, so that is for negation of a vector. We have null or zero vector. A zero vector or null vector is a vector whose magnitude is 0. Okay, we are going to consider that when we start the mathematical application. We denote a null vector by the term 0. The direction of the zero vector is arbitrary. That it doesn't have any specified direction. We have what's called equal vectors. When two or more vectors are equal, that means that they have the same magnitude and direction. They have the same what? Magnitude and direction. We can consider an example. When you look at an example of equal vector, we have vector AB, maybe a line AB, okay, which is given as AB is a vector. Then we have another vector PQ, the same length. We have P and Q. Okay, this one is given as PQ. If they are equal, we talk about equal vectors. If they are equal vectors, that means AB vector AB is equal to vector PQ. Vector AB is equal to vector PQ. Okay, so that is for equal vectors. So these equal vectors can have values. If vector AB, we have vector AB is equal to 10 newtons, and that means PQ vector will be equal to 10 newtons because they have the same magnitude. Okay, we have parallel and collinear vectors. A parallel vector or two vectors are set to a parallel if they are acting parallel to each other in a straight line, such that the two of them are at infinity, they don't meet each other, or you call them collinear. That means they are linearly separated from each other even at infinity. So we have two vectors. Maybe we have a vector P1, P2 acting at a constant distance from another vector P2, or let me say P3, P4. Okay? The distance is constant. That means vector P1, P2 and vector P3, P4 are parallel to each other, and they are also collinear. We have like and unlike vectors. Like and unlike vectors. Like vectors means that they act in the same direction. Two vectors that act in the same direction are called like vectors. We have a vector. Let me call this vector A. I call this vector A, and we have vector B. And they are acting in the same direction. We call them like vectors. They are acting in the same direction, like vectors. But if they are acting in opposite direction, let me say vector A or vector P and another vector Q. Acting in opposite, you call them unlike vectors. So these two vectors are unlike. That is vector P and Q are unlike. But vector A and B are like vectors because they are acting in the same direction. Vector P and Q are unlike because they are acting in opposite direction. Okay, so that is for like and unlike vectors. We have what we call position vector. When a vector OA is used to specify the position of a vector A relative to another point O, the vector OA is called the position vector of A, referred to O as the origin. Okay? And in this case, as shown in the figure, A is OA and B is OB, are the position vector of A and B respectively. The vector AB is determined as follows. AB, which is the length AB, will now be the position vector AOB subtract position vector OA. We give us vector. That means if we want to find the position vector with respect to the magnitude of the size of the length of the vector specified, then we can apply this triangle law to solve such a vector problem. So here, our focus here will now move to what we call addition and subtraction of vectors. When two vectors are added, when you add two vectors, therefore you have what we call a resultant vector. We have something like this is vector A and another vector B. If the resultant vector is C, we can say that C is equal to A plus B. Okay? C equal to A plus B. Okay, we can call it this a vector, this is another vector, and this vector C. So vector A plus vector B will give us vector C. So vector C is a resultant vector of A, vector A and vector B. Okay, so this is the resultant vector. The term resultant of a vector is the combination of two or more vectors in magnitude and direction to give a single vector that have magnitude and direction. That is resultant. As in subsequent times, we are going to look at resultant vector with respect to what we call parallelogram law of vectors. Okay? Parallelogram law of vectors will be considered, and we'll see how to apply it in solving vector problems. So we can also look at subtraction of vectors. When two vectors are subtracted, that means the direction of the vectors are considered. And when you consider it, it's just like adding in reverse order. As shown in the diagram, we have C, A, B, C. And A is vector A, and BC is negative vector B. So if you want to have the value of AC, you add them in reverse order. Just like when you have this, okay, and we have this acting in this direction, and this one acting in this direction, they want to find this. Let's say that this one is A, and this one is B. I want to find C. To find C, since this is acting in opposite direction, we have C equal to vector A, subtract vector B. Okay, with that, you can get vector C as a resultant of vector A and B, but using subtraction of vector concept. Okay, so that is vector addition and subtraction. Okay, right now I want to look at what we call the I and J concept of vector. The I and J, or orthogonality of vector quantities. What do we mean by that? First of all, we look at the XY axis, XY plane. In the XY plane, we have X and Y, and we have a function. Let's say this is a vector F. Vector F is represented by these 2 points from O. So if I call these 2 points from here to here, okay, this one is at this point, we call it XI, I unit. And here, from here to here, we have YJ, YJ. So vector F, that means vector F is equal to XI plus YJ as a vector. So with that, you can find the modulus, or what we call the magnitude of vector F. And the modulus is the absolute value of the vector. Modulus of F is equal to F modulus equal to XI all squared plus YJ all squared. And this one also will be squared based on Pythagoras theorem, because here is 90 degrees. So with that, we can say that the vector F, or the modulus, is the square root of X squared plus Y squared. And that will give us the magnitude of vector F. Remember or recall in mathematics that I squared in complex numbers is 1, and J squared also is 1. But certain rules are applicable here when you are dealing with vector notation in terms of I, J, and K notation. Then you know that I dot J is equal to 0, I dot I is equal to 1, J dot J is equal to 1, J dot K is equal to 0, and I dot K is equal to 0. Take note of these rules, because it will guide us as we move ahead with the next subsequent slide. Okay, so we have been able to establish the modulus, or absolute value of vector F, using Pythagoras theorem. Let's see how we can find what we call the unit vector of a vector. What is the unit vector? When you say the unit vector, let me say unit vector F is given as vector F all over modulus of F. So let F be given as 2i plus 3j. If F is a vector which is given as 2i plus 3j, that means the unit vector of F is equal to vector f over modulus or absolute value of f. So we get the modulus of f as square root 2 squared plus 3 squared. And that is equal to square root 4 plus 9, and that is root 13. So we have root 13. So therefore, the unit vector will be equal to f. That is, that is f unit vector is equal to f, which is 2I plus 3j divided by root 13. So we can write it like this, and that is the answer. So that's for unit vector in terms of the ij parameters. So we can get other vectors when we talk about addition of vector in terms of I and j properties. When we talk about addition, how do you add and subtract? Add and subtract vectors of this nature we are given. Given that a vector is 3i minus 4j and b vector is 2i plus 5j. Okay? A plus b will be equal to, just add them together, we have 3i minus 4j plus 2i plus 5j. So you add corresponding parameters. We have the j's added together and the i's added together. So that will give us 3i plus 2j, then minus 4j plus 5j. So we have 3i plus this 2i will give us 5i, minus 4j plus 5j will give plus j. That means plus 1j. So you can say plus j. So we have the answer. So a plus b vector is 5i plus j. Okay? So if we are also asked to look for the modulus of a plus b, modulus of a plus b, from that or from what is given, a plus b modulus or magnitude of a plus b, you just find the square root of this. You have 5i all squared plus j, which is 1j all squared. And that is the same thing as 5 squared plus 1 squared. 5 squared is 25. 25 plus 1 is 26. So you have square root of 26. There's only looking for the square root with your calculator. You can leave it that way. So that is for modulus or addition and subtraction of vectors. So we can look at some examples on subtraction and see how we can relate that. So we are given again, we are given this vector A equal to 6i minus 5j. Vector B is equal to 3i plus 4j. And vector C is 2i minus 4j. And we are asked to look for A plus B plus C. That is 1. And we also look for 2a plus 3b minus c. I will solve the first one. I'll leave the second one for you to scramble at home. Okay? So let's see how we solve the first one. We have A plus B plus C. So we have the three vectors. A plus B plus C is equal to A is 6i minus 5j, and B is 3i plus 4j, and C is 2i minus 4j. So that will be equal to, you just add the corresponding sides, or let me say corresponding values that have the same I parameters, and that will be 6 plus 3, which is 9, 9 plus 2, and we have 11i, and we have j, 5j minus, this will give us minus j, minus 4j will give minus 5j. So at the end, the final answer there is 11i minus 5j. Okay, so that is vector A plus B plus C. And sometimes you can multiply certain numbers with their scalars. The 2 we see here and the 3 here are scalar multipliers. Okay, so if you want to deal with that, 2a will be 2 brackets 6i minus 5j. And that will be equal to 2 multiplied 6 is 12i. 2 multiplied 5 is minus 10j. So that is vector 2a. When you have the multiple of a, that is multiplying vector A with scalar multiplier 2 will give us that. You can do for that of B. using 3. So at the end, you can be able to simplify what we have there. So if you are given a vector notation or vector in this form, you need to find how you can simplify it using what has been given. Okay, so that is for that. We look at the other aspect of vector in terms of projection of vectors. And the projection of vector here we are looking at has to do with projection of vector A on vector B, or projection of vector B on vector A. How do you find the projection of a vector from one A vector to another vector? So we say projection of vectors. If you project vector A, project vector A on B, that will be equal to A multiply B unit vector. A multiply B unit vector. So that means A multiply B over modulus B. So if you are given vector A equal to 3i minus 4j and vector B is equal to 3i plus j, and you are projecting, find A dot B modulus. To do this, you multiply this and say 3i minus 4j, okay, multiply by vector B, 3i plus j, then the modulus of it, which is 3 squared plus 1 squared. And that is equal to 3i minus 4j, bracket 3i plus j, all over, we have 9 plus 1, 10. So we have root 10. So we can expand this. When we expand this, we have 3i multiply 3i is equal to 9. 3i multiply j is equal to 0. 4 multiply this is equal to 0. And 4 multiply this is equal to minus 4. All divided by root 10. Final answer is 9 minus 4 is 5 divided by root 10. Okay? So we can rationalize that as well and say root 10 over root 10 is equal to 5 root 10 divided by 10. So 5 cancel here, we have 2. Final answer, we have root 10 divided by 2. Okay, that is the final answer for this particular question we have here. Okay, so that is as far as we can go in that aspect. The other aspect we are looking at has to do with multiplication of two vectors. Okay, to multiply two vectors, you need to consider the parameters in terms of I and j function. So when we multiply two vectors, you must take notes of the parameters, two vectors. So we have vector A is equal to 2i plus 3j, and vector B is equal to 3i plus 5j. So that means A dot B vector is a multiplication of vector A and B. And that is equal to 2i plus 3j dot 3i plus 5j. So we multiply them based on the rules. 2 multiply this is equal to 6i squared, that is 6, because we said that I squared is equal to I dot I, and that is 1. And j squared is equal to j dot j, and that is 1. However, I dot j is equal to 0, and j dot I is equal to 0. So when we multiply 2 multiplied by 5j, it is equal to 0. 3 multiplied by 3i, 3j and 3i is equal to 0. 3 multiplied by 5jj, we have 15. So we add the numbers. 6 added to 15 is 21. So the answer here is 21. So that is for multiplication. So you can attempt these following questions. You can just attempt them as your exercise. Okay, we have this one. 2i plus 7j dot 3i minus 4j. And we have the second one, 3i plus 4j dot 10i minus 3j. And we have the third one, I'll just give you 3, 4i minus 5j close dots, 3i plus 6j. So just do this, and also reference other materials and textbooks and solve more problems so that you'll be able to apply it in solving other problems. So in subsequent class, we are going to look at vector in 3 dimensions. So this is vector in 2 dimensions. We will be looking at application in finding area of a triangle, parallelograms, and other properties of vectors. So I want to appreciate each and every one of you for participating in the class, and continue to listen to the class and remain blessed. Okay, thank you for listening.